Hello everyone and welcome to our crash course on data cleaning with Python. By the end of this particular crash course, you will have covered the following core concepts: how to perform standardization on a dataset, how to handle syntax errors, how to handle irrelevant data, how to find duplicates and handle them, how to find missing data and handle missing data, and also how to find and handle outliers. So this particular course is a bit more interactive, which means that when we're going through each and every section, you can also be going through the same section, um, and also running the examples that we're going to be running, and also work on the challenges which will have been provided in the notebook that we'll be using. So with regards to the prerequisites, it's expected that you have some understanding of Python, programming language, um, just having an understanding of the core concepts, which are covered in another course called Python Basics for Data Science. That's also linked at the description of this particular video. The same case with data wrangling with Python. If you haven't gone through this also other course, you can also do so. Having a feel of both courses will be important because the prerequisites, the techniques that we're going to be used would have been covered in both courses. If you've gone through the data wrangling with Python course, however, some of the concepts that we will cover in this um, course will be repetitive. You might find that we are actually going through what you have gone through, but do take it as a crash course on data cleaning with Python. That way, as you move forward in your learning journey as a data scientist, you're able to feel confident that you can apply the data cleaning techniques outlined in this course with confidence. So in the description section, you'll find the practice notebook, which we are going to be using. And if you'd want to work on the challenges and also get a solution notebook, you can also follow the link to the same course hosted on other external platforms, which will also be linked. So be sure to do that. If you have any questions, feel free to post them in the comment section. Hopefully others will be able to help you answer them as well as myself. But if you also want some quick answers to the problems that you might have, you can join the Afterwork Data Science Community Support Platform on Telegram, which will have, which I'll provide the link to that particular course, that particular platform also in the description section. The next course after this, once we have gone through this course, you can go through now the data visualization with Python course, which will cover how to apply, how to create various visualizations using the Python programming language. So, okay, so I think we are good to go. So we can get started with this session. So the first thing that you're going to do is to go to the description section and you're going to open the notebook the notebook link. Just click on that link, which will direct you to this page. And this is a notebook that we're going to be using for this crash course. So make a copy of it because it's a Google document. The platform you're using is Google Colab, which is a variant of Jupyter Notebooks. I would recommend we use Jupyter Notebooks. We use Google Colab for this. Otherwise, you might experience some errors or some problems if you use different platforms. But nonetheless, the same functionality that you would get in using, say, Jupyter Notebooks hosted maybe locally or even in another environment would be the same that you'd get here, only with a few slight advantages. Okay, so go to File, then save a copy in Drive, and this should open it should open a new tab, which will have a copy of this particular document that you can be able to edit, and you can use that particular document for your analysis. So once you have your own copy, just connect by clicking the far right. There's a button that says connect. Click on that button and it's going to connect your notebook to Google servers, which will run our code, our Python code. That should take a few seconds depending on your internet speed. So once we're done, then we can start. So there are various techniques that we can perform while performing data cleaning with Python. Um, there are standardization techniques, the syntax errors, how to handle syntax errors, irrelevant data, duplicates, missing data, and outliers. I'll be going through each one of them and showing you how we can be able to apply those techniques. So let's start with standardization. The first thing that we're going to do is to load the prerequisites with regards to the libraries that we're going to be using. We're going to be using Pandas, which is a library for performing data analysis and manipulation. And then we're also going to import also NumPy. So NumPy is another library for performing scientific computations. So it helps you with functions which are able to perform some complex mathematical operations. So Pandas, in any place that we use PD, we'll actually be referencing Pandas, and in any place that we use NP, we'll be referencing NumPy. So let's run those two cells by clicking the button on the top left. They should be loaded. Let's now start working on the standardization examples. So standardization really refers to the preparation that you make to a data set that makes it easier for you to perform your analysis. The common type of standardization approach method that we're going to be applying on our data set would be to rename our column names, majorly because column names would need to be cleaned up if you would want to use them, if you'd want to reference the columns or the variables later during your analysis with ease. So sometimes you might have column names that have capital letters, others have lowercase letters, others have mixed, capital and lowercase, others have multiple words within the column names, and it becomes harder for you to be able to reference the variables that you'd want to reference to the variables that you would want to work with. So in our particular case here, we are going to be referencing column names which are cleaned up. So the first thing that we're going to do is to work with this particular data set. This data set, it contains just dirty data. It's a small data set. However, you might notice that I have included this particular separator as a second argument to the read CSV function provided by Pandas. The reason is because the dataset columns are separated by this particular separator. So if I just remove that for your reference, but before I do that, let me just use playground mode so that I don't make any sort of edit to the original copy. So I'll just use playground mode, just take a bit of some time, a few seconds. So it's something that you can use with regards to Google Colab. So playground mode just allows me to be able to do anything. It's like a sandbox environment where you can just make any sort of changes and errors without affecting the original notebook. You could also do that with your own notebook, but you can just edit for now your notebook. So let's just remove the separator and see how the dataset looks. So the first line reads our CSV file from this particular location URL. Then we print out the first 5 records. So this is something that you'd go through the data wrangling with Python workshop course, crash course. All right, PD is not defined. We need still again to load pandas and also NumPy, but NumPy for later nonetheless. So if we rerun this, should be able to get our first 5 records. So you can see we have our column names, our columns separated by the semicolon separator. So what I'm going to do is to put define the separator as the second argument. So in our case, we should have a good data set now that can be easily read. All right, so we can see that we have column names which have capital letters, and they are column names with two words. So yeah. All right, so in order to clean the column names, what we are going to do is to convert all our column names into lowercase, and also we're going to replace the spaces between the two words that we have for column names with an underscore. So we're going to use two methods. The first method that we're going to use is one where we strip, so where we use functions to perform those operations, and there's another method which we're going to use our own column names and replace the existing column names with our own defined column names. So just to show you how we can be able to print out the columns, this is how we can be able to print out our columns by referencing the data frame df.columns, and we have our columns, as you can see here. These are the columns in an index form, but this is a list. So here we have all the column names. So we're going to replace all these column names with now column names that we have been able to apply functions to. So by applying functions, we are going to use various types of functions provided by pandas. So here we are replacing our existing columns with now the new columns. So we first of all get our columns, which are here. Then we apply this function strip .str.strip, and this particular function will strip the leading and trailing spaces. If our column names have spaces before and after, then we will remove those spaces, but in our case we don't. It's always good to have that, just in case you might have such spaces. Then we're going to apply another function, which is string.lower, which will convert all our characters within our column names to lowercase. Then after that, we are going to replace any space that is within our column names, like this space over here and this space over here. We're going, which is this, which we have defined here, we're going to replace it with an underscore. So that space will be replaced with an underscore. Then after that, we're going to apply these two functions. The last two functions are replace functions, and what would be happening, we are going to be replacing any character within our column names that looks like this, which is a left bracket with nothing. Here we don't have any space. So the function will look for any character of such nature. The same case with the last function, it will look for this particular character, but we don't have them here, so that's okay. So if we run this, we are going now to get column names which are don't have any spaces leading or at the very front, or trailing spaces at the very end. We're going to have column names which don't have capital letters, they will be all in lowercase. We are also going to have column names which will have which won't have any spaces in between. And yeah, so let's just print out our entire table to just see the change that we have been able to make. So you can see we have cleaned up column names, so we can easily reference these column names later. as we will get to see. All right, the second method that we can be able to use when we are standardizing our column names, our data set with regards to the column names, is to define our own column names and then replace the existing column names with now our new ones. So in our case here, we have a list which we have defined. The list contains elements which are actually column names, our own column names, and we are going to be replacing our existing column names with now this new list, and we print that out. So here the first line, we just reloading our dirty data set, and here we're just performing standardization, then here we're just printing out. So if I run this, you should see that we have our clean column names. But this particular method is not scalable. I wouldn't recommend this method because you can make mistakes while you're defining your column names. But this other one actually happens automatically with regards to the functions actually act on the column names as opposed to you being able to define each one of the column names manually. So assuming you had 3,000 or 1,000 column names, it's recommended that you use this method over this other method. Okay, the next example. So if we wanted to apply the same standardization to a particular column, so it's the city column, we wanted to ensure that all the values within the city column are lowercase or are uniform. And in our case, we're going to say I'll have lowercase values. Then we can be able to use the strip function, one of the functions, and in our case we can use str.lower. So we first of all define the column that we would want to apply this function to. Then we apply the function to that particular column. Then we replace the outcome of that. We replace the original values of that column name or column with now our new values, which have been cleaned up. And as you can see, we have Lisbon and London, which are capital. But if we apply this technique, you can see that we have our city column with our city variable with lowercase characters. So you could actually apply the same functions to all variables that you have. All right, so the next method that we are going to cover is being able to perform now operations, mathematical operations, with the intention of, say, converting the variables to a particular scale. So assuming that we had our height over here has values which are in inches, and we wanted to convert these into centimeters. How do we do that? We would reference our height, then we would multiply that by a particular number that would help us to get to our outcome. So in our case, 1 inch is 2.54 centimeters. So we would multiply the values of height with 2.54, and then the outcome of that would we would actually replace our original values with the outcome of that. So this is actually what we are doing here. So if we run this, we should be able to have our height have different values. So these values are in centimeters now, as opposed to their original values, which were in inches. Okay, so the next thing, we might want to convert our various variables to have a particular data type. Suppose that we have something like account B and total account, which are, as you can see, they're all in integer form. We might want to have them in float form because probably it makes sense that way, considering that the values that they represent are currency. Currency sometimes might have decimal points. So we're going to see that, but let's see what we can be able to convert. So first of all, we're going to find the data types of the existing data by simply using the dtypes property. We learned this in data wrangling course, and 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 once we have a look at the data types, so the first data type, that's the name variable and the city variable, and also the country variable, have the string data type is from Python. Object represents string. Then when it comes to height, it has a float. Same case, weight is float data type, and account B and total account have integers. So we might want to convert maybe one of these two floats. But in our case, as an example, we're going to convert height into integers, so that you have a look at that. Maybe it makes sense to have height as integers because the decimal points don't really have any they don't mean anything. Okay, well, they could mean anything, but for practice purposes, let's convert the height into integers. So again, we are going to have our original height values being replaced by our outcome here. So here we are referencing the height column, and then we are applying that column with an apply function. So we're using an apply function to pass a particular operation, and in our case we would want to apply this format to our height values. So we use numpy np.int64 to define that we would want to have integers, the integer data type applied to our height variable. So once we apply this and we check our data types, we should see that we have been able to convert our height into integers. So here, originally we had float 64. If we run this, we should be able to see that we have our height as int 64. Okay. So we can also just have a look at those values just to see how our height values have look like right now after that particular change. So you can see our height values are actually integers now, as opposed to them having been float values in nature. Okay, so there are challenges, but as mentioned, challenges you can go through them by following the external links just for more practice. Yeah, so you can sign up on those platforms which I'll have provided. Yeah. Okay, syntax errors. So we might have a data set that contains errors. By errors, it could mean something like let's see, like Germany. You can see in our data set here we have Germany, which has some error. So Germany is usually a single Y, and we might want to fix that. How do we do that? Let's see how we can do that. So we use the replace function. So we would reference the column that we would want to use or to fix our syntax error. And that syntax errors can be just spelling mistakes or typos. And we apply the replace function. So the replace function would check for the original value of what we would want to replace and the new value. So the new value would be Germany, which is corrected. So the outcome of this would replace now the values which have Germany with this new value. So if we print that, we should be able to see that Germany has just that. Okay, so we might also decide to strip or remove the leading or trailing spaces. So the spaces in front, maybe you might have some space in front of, let's say, let me just print that out, the city column, city variable. Yeah, so you might have some spaces in front of London, Stockholm, Brussels, Berlin, or some spaces afterwards. This might be important. It's an important operation to apply while you're cleaning your data set. If, say, you would want to export the data into a different environment, like maybe, okay, in Excel form, where it's going to be, where analysis would be performed, and when you're visualizing your data on, let's say, Excel or any other platform, you might see that the data is not really arranged, even though you can fix that with just simply clicking on alignment. Sometimes it's important to just be able to have a complete clean data set that you'll um, have have cleaned with Python before giving other stakeholders to work on that data set. So how do you get rid of this space and also some spaces after? Then you use the strip function, which we used earlier on while we were working with the same function to rename our column names. We would reference our city column, then we apply the function that we would want to use, which is the strip function. Then replace the old values with that new operation, which with that new outcome, then print out our new values, which you will see here will actually be cleaner, and they don't have leading or trailing spaces as shown. Okay, all right, so work on the challenges, and once you've worked on the challenges, then we can continue to the next section. So irrelevant data. So sometimes you might have a research question that requires you to only use maybe 3 or subset of variables in your data set, and you have a data set that has, let's say, 10 variables, and your research question only requires that you use only 3 variables. How do you go about removing that irrelevant data? The most common method would just be to drop those variables, and we're going to see how we can be able to do that. Um, hmm. Now we have been working with this data set, which is this data set, and we are now going to drop a few variables, having in mind that maybe we might be required to work with only a subset of the data set. We are going to drop our city column, and how we do that is through the use of the drop function. And the drop function usually takes a few parameters. It takes the city parameter, and also, or not the city, the variable names that you'd want to drop. And that has to be in a list as shown. It also takes the axis that you would want to reference. When the axis is 0, that means you're referencing the rows. When the axis is 1, it means you're referencing the columns. In our case, we would want to reference the columns, which means that we would want to drop a column which has this city value. Then the in place parameter is actually used to make changes to the original data frame without replacing it again, by simply just executing this statement. So in place, when we say in place is true, whatever will be the outcome of this particular statement, or the outcome of running this particular code, will actually replace what was there originally. So if we are to run this and preview our data frame, we should see that we don't have the city column. So if I run this, you should see we have name, country, height, weight. And in our original data frame, we had name, city, country, height, weight. So city has been removed. If we wanted to drop multiple columns, we can then be able to do that by simply adding another element or all the elements that we would want to delete or to drop in the list that we give to our drop function as the first parameter. So here we might want to drop height and weight, which is here. So running this will also drop height and weight, and we should have name, country, account A, account B. All right. Okay, so let's continue. Now, I'm going to give you now this example. This is a perfect example of how you can also fix what I refer to as in-record or cross-dataset records. And this is up to you as a data scientist to figure out what makes sense within your dataset and what doesn't make sense. In this particular dataset that we are working with, what makes sense is that account A plus account B is equal to total account. So the sum of account A and account B should equal to the value here. However, if we look at a few values like the fourth value plus this other value for account B, it does not equal to total account. So it means there's an error there, which actually does not make common sense. So how do we fix that? So how we can be able to fix that is there are many ways. We might decide to perform an addition of this and this and replace the 300 with the new value. But I'm going to walk you through how we can go about that particular problem. So the first thing that we would want to do is to create another column that's total accounts B or 2, and that column will have the values that make sense. So we will do a sum of account A and account B, and then we have our values in that column. Then we are going to compare that column of that new variable with now total account and check on whether those values are equal. If those values are equal, then we will create another column, and in that other column we will have a value true or false for each and every record. Then we can be able to narrow down by, say, filtering, like fetching for records which have false value of that final column, and then we can be able to perform some operations. By filtering or fetching, those are techniques which are covered in the data wrangling course. So be sure to check that course before you go through this. Or you can still go through this, but go back to that course as well. So the first thing that we're going to do is to create a new column, total account 2, and say here total account A plus total account B should equal the values, the sum of those two values, those two variables should equal to total account B. So if I run this, I should have another column at the very end which has total account 2. Then, so once I have been able to create this, I'm going to create another column or variable which will compare the values of these two columns, that's total account and total account 2, and set the values for that particular column to either true or false. So the next step, we are going to create our new column saying total account question mark, and we're going to use NumPy to check for whether those two variables have same values, and then we're going to reference NumPy, then use the where function. So and put our condition within as our first parameter within that function. So where this particular condition is equal to true. So where this particular condition evaluates to true, then we are going to have true value being given to that particular respective record for that variable. So if this particular statement turns out to be true for the first record, then that first record will have the value true for this new column, total account. The same case with false. So if we run this, we should have a final column which has total account is, so you can see here, total account, this is the new variable, which has true or false values, which really check on whether total account 2 and total account variables are either true or have equal values, and if so, that particular record has a true or false value. Then the last thing we're going to do is to fetch now the records which have false, which actually don't match, and we can use the pandas.log method. And in this particular method, we have our expression, which would want to fetch, which would need to be true in order to get the records. So we would want to fetch records which have total account question mark as false. As you can see, these are the records which have those in record errors, and then we can do something to this, which is either correct the values or drop these particular values if they don't make any significant impact to analysis, or even decide to leave them as they are, maybe for certain reasons. Maybe if they are not their effect is not negligible, but we would still need them. So to determine also the length or how many records there are, if we had a big data set, we could use the dot length function. So wrap our statement here with the dot length function, which we have. So we have 3 records. Okay, so work on the challenges, then we'll continue to the next section. Duplicates. All right, so duplicates would be just records which have been repeated in a data set. Maybe someone, maybe there was a mistake within the system that you are collecting data in, or maybe record was genuine, or maybe it was not. It's important to also check for duplicates. So the first thing that we are going to do is to load our new data set, which we are going to be working on for this particular section. So we are going to load it, store it in our df data frame. Then after that, we are going to print out the shape, the size of the data set. Whoops. Okay, all right. So I see what it's read CSV. So here we have 458 records and 9 variables. It's a concept covered in data wrangling. Okay, so if we wanted to identify which observations or records are duplicates, we use the duplicated function. And how we can be able to do that is to reference the excuse me, the data frame, then use that particular function by saying df.duplicated. And if we run this, we should be able to have our duplicated records stored in df, or and do something to that particular record, or we could still find the sum of those duplicates by simply finding the sum. We could, let me see if we have covered that in the next section on how to preview. Okay, we haven't. So we can be able to preview those particular records by saying df.head. So here we should be able to see our duplicated records. So we're just waiting for that to run. .head will print out the first 5 records, but we might have maybe 100 or 1,000. Hence, you can use the sum function, which is in the next section, or you could use the shape property, which we used here, to also determine the size of our data set. So this is taking a bit of some time, but let's see. Okay, so we have this output because we don't have any duplicates, but essentially we would have duplicate records. And this is important because it might help us to determine, to investigate those records if we print them out, if whether they are genuine or not. So we could also find the number of duplicates by simply using the sum function, and if we run this, we should be able to see we don't have any. Okay, example 2. So dropping duplicate columns, we might want to drop those duplicate columns by simply using the drop duplicates function, which you can see here, and applying that to our df. And this particular, here we are just actually storing them in this particular variable. And if we run this, we shouldn't get any because we don't have any records. But let's see, let's print this head. We shouldn't have any because we don't have any duplicate records. Okay, if we wanted to drop duplicates with a specific in a specific column, so all records with duplicated country, in our case we would specify the country variable, or the variable that we would want to use for our condition with regards to dropping the duplicates, and we would specify those variables through a list and passing it to the duplicated function. And if we run this, we should be able to see the records. We can also print dotted or even leave it as it is, but we should be able to see those duplicate records. Okay, so we actually do not have any. So all right, so the next thing, if we wanted to drop, okay, just a second, I think I have seen. All right, I think we should be good to go. If we can also create a new data frame which will contain a copy of the duplicate records by simply doing what we did even earlier. I think we also did something like that earlier. And we can see the shape. So we can see that using the shape property as opposed to using the sum, which we used here, you can see that we have 0 records and 9 variables. All right, work on the challenges, then we'll continue with missing data. So missing data. Sometimes data can have missing data. So you might have records which have certain values filled in for the variables that you have, but certain values are not filled in for other values. So you might have partial data in your data set, and it's important to have a complete data set that has complete data in any case. So how do we go about that? The first thing that we can do is find those missing data, There are many methods, but we're going to start with the basic ones. Probably we would see why they're not really important. They're not the best methods, but later we can see that these are actually good methods that we can use. So we can check if we have any missing values in the entire data frame as shown using the isNull method, but this is not the most convenient. This just tells you whether there are values which are missing or not. So let's do this. I think we should read this data set again. Let me just read this data set again. df dot pd dot read csv. All right, so if we run this, we should be able to see that we have, oh, sorry, we need to put a separator. Boom. Oh, I see. Just a second, I need to check on something. Okay, good. I think we're good to go. So the first thing that we can do is load our data set. Then we check whether our values within our data set have missing values, so, or whether those values are missing. So we use the isNull function. So you can see in any place that you see false, it means there are values there. But you can see there is a true here. There's also a true here, which means they are missing data. There's missing value. There are missing values there. And missing values can be represented in various forms, like, NaN, not a number, or even null. It depends with whatever. It also, so pandas can be able to differentiate between the values that have such values and also values which have now the actual values. But it's also important, sometimes you might find that it's also important to know how missing values have been represented in your data set, so that you know what to filter for when it comes to finding that missing data. Yes, you could use some even techniques like filtering techniques to say, like, find records where, like the way we used NumPy, find records where this particular column has 0, and that it could be that 0 has been used to represent your missing data. But in most cases, we would have, let's say, NaN, and we are assuming that NaN is the missing, it represents the missing value, a missing value in our case. So this may not be the most convenient method, because you really cannot be able to say, you cannot be able to go through, let's say, 1,000 records if you had many records in your data set. So we could want to also use the same method, but check for missing values in each column. And again, this may not be the most convenient, but in some cases it may. So in our case here, it says, the output says that we don't have missing records here, but we have here in weight and account. So you would want to act on that. We could also check how many missing values there are, how many of them, rather than knowing just whether they are. So in our case, we have weight and account A having one value missing in terms of variables each. We can see if we have any missing values in the entire data frame by just checking whether it's true, by having an output whether it's true or not. So if we run this using the any function as well as the dot values, so here we can see that our entire data frame has missing values. So just a quick way of getting to know whether we have any missing data. We can also count the total missing values by we're using this particular method, but having some at the very end. So if you check, it's almost similar. Actually, it's similar to this. So it's just a repetition of the same. Okay, so example 2. If we wanted to, now how do we deal with data? There are many ways of dealing with data. The first way would be to drop if that particular data has no significant effect on the overall analysis. You can drop that those particular missing records. You could impute those missing records with mean values. Maybe you have a column like weight and account, which have missing values, so you could do the mean of all those other values within that variable and use the mean as the now value for that missing value, or median. In some cases they do, it works well, in some cases it may not. We could also do what is referred to as imputation by regression, which is using some machine learning techniques, but that's a bit more complex for this session, for this course. So you would learn from the existing records on what's a reasonable value for the missing values, and use those particular values from mean imputation, from regression imputation, from imputation by regression, to act as now the new values for the missing values. So there are many methods that we can use, but in our case, we're going to be learning two. The first one would be just being able to drop missing data. So assuming we would want to drop records which don't have any values, like they don't have any values for each and every column, which sometimes could be the case. Then how do we do that? We use the drop and a function, and we give it the parameter how with the value all. And if we run this, we should be able to see a data set that's cleaned. Okay, this is cleaned. Well, we cannot be able to know that not unless we say shape to see it's 8 8. Our original data frame had 8. So if we even have to, we can check. Okay. We can also drop columns if they contain missing values, such as shown. If we want to drop just columns, in our case initially we were dealing with rows. If we would want to drop just columns, we can specify that we are working with columns by using the axis parameter and with a value 1, and that would now drop columns without any values. That sometimes could happen. So dot shape should have 8 8 because we don't have such. So we could also drop rows or records that contain less than certain observations. Like, if you have a record that contains more than 5 missing values or less than 5 missing values, you could use the threshold parameter to specify that particular condition. So if you want to see a bit more about how you can be able, what, let's say, threshold means, you can even drag your mouse. Let's see whether it's going to allow us. No, I just wanted to show you a way of having a look at what even threshold means from the documentation, but it's okay. So you can say if rows contain less than 5 observations or 5 values, then drop them. If they contain less than 6, then drop them. So there has to be a threshold, so for those particular records to be considered in your data set. Lastly, we could drop all the records which have missing observations, even if it's 1. So if we run, did we run this? I think we did. Okay, if we run this, we should be able to see 6 8. So we had two records which had missing observations. All right, example 3. We might also want to flag missing values. So this is another method of handling missing data. We might want to flag them as by flagging, it could be, you put some records which would inform other people that you actually have missing data there. In our case, we might want to flag those missing records by having a 0 replace, let's say, the NaN. So our original data set, I'm just going to go back here. So you can see here, this is the data set that we are working with, and it had NaN as the missing value, and same here. So what we could do is just replace the NaN with 0, the value 0. And how we would do that is to use the fill NA function and give it a parameter 0. That's the value that we would want to act as one that represents our missing values. The first line here, we use the copy function to copy our original data frame and save it in df2 so that we still retain our original data frame df. Okay, just a second. Just putting some power. Whoops. Sorry about this. Okay, so if we run this, we should be good to go. So you can see we had NaN here, excuse me, which has been replaced, and we also have NaN here, which has been replaced. Okay, work on the challenges, and once you are good to go, then we can work on outliers. Okay, outliers. Um, in a data set, you might have records which are way different from, the many records that you have. You have that one outlier, that record that seems to be a bit different than any other record. And this is actually sometimes important when you are working with, let's say, just to give you a good example, maybe you're working with a banking data set, then in your transactions, daily transactions, you see that when you're analyzing your daily transactions, you realize that, whoa, you have a transaction from an account, well, not even from an account, just a transaction that's way above all these other records or these other transactions. And you would be curious, you'd want to investigate to see whether that's a genuine outlier, or maybe whether you've been hacked or something of the sort, or so as a data scientist, it's also important to be able to identify outliers. In our case, we're going to be working with now a method that's called the Iqr method to identify um, our outliers. So we are going to load our new data set, which will contain just countries um, uh, data. And our country's data has some value. There are values which are way different from others. You might find this GDP per cap 779, but you'll find GDP per cap of 50,000, which is okay, it's genuine, but we are going to use this data set for learning. So first of all, let's print out the shape of our data set, which is 1,704 and 6 variables. Then the method that we're going to use, as mentioned, is the Iqr method. And in this method, we usually consider a data point becomes an outlier if it is more than 1.5 the IQR above the third quartile or below the first quartile. So in statistics, they're what are referred to as IQR, which is the interquartile range, and 50% of your data would lie between 25. It's between the first quartile and the third quartile. So 50% of your data would lie between that. But if you have data that lies, and that particular range is referred to as the IQR. But if you have data that is more than 1.5 that range above the first quartile, or um, or below the first quartile or above the third quartile, that particular point is usually referred to as an outlier through the use of now this Iqr method. So in our data set, we are going to be considering our numerical values to be able to figure out what those records are. So the first thing that we do is to define the first, the Q1, the first IQR, and Q3, which is the third, um, um, which is Q, which is the third quartile, first quartile, third quartile, and also define our IQR, which is the interquartile range, which is Q3 minus Q1. Then we're going to fetch for records which are, as mentioned, 1.5 times 1.5 the IQR above the third quarter, and 1.5 the 1.5 the IQR below the first IQR. So the first condition, so we're going to first of all define the variable where we're going to be storing our outliers. Then we're going to be using we are referencing the data set that we loaded here, the very top here. And we're giving this particular data set, we're going to check for the first set of condition. We're going to to check for outliers which are below the first outlier by giving this particular condition, below the first quartile, sorry. And also then we're also going to also check for the values which are above 1.5 times the third, 1.5 the IQR above the third quartile, and we're going to look for those values, and in that case then fetch those records, store them in this particular date variable, and then print out that particular data frame. So if you can see, we have 317 records out of the 1,704 records. So once we have that, we can then explore those outliers to just investigate and see what's happening. Like, are they actually really genuine? So I think this didn't. Okay, yeah. So shape. Okay, head. Is it head? We can even do. We can just print them out the way they are. And once we print them out the way they are, we should be okay. Then we can investigate. You can see these ones. There were the GDP that we had seen while we were previewing our dataset exploring. There were around 700, something below 1,000, but we have quite some outliers which have quite large numbers, whether it's large or even quite low numbers. That's also a consideration. Same case with also the population. So what's being considered here are just the numerical values, but we could also always convert our data here, the category, this data which is categorical in nature, into numerical values if you wanted to. Okay. Right. So here we can say that so as mentioned, we can handle these outliers by either leaving them if they're genuine. In our case, we could actually leave them. We could replace those values within. We could replace those values which are outliers with now genuine values. We could also either drop them if their outcome, or if dropping would not affect our analysis. So if we drop them, so to drop them, what we could do, an easier way of dropping them would be to use what is referred to use this particular character, which would just refer to the other part of the data set that does not have outliers within our condition. So this character, here we are getting, so in our case, in this statement, we are getting our outliers, but if we don't want to get outliers, we just put that character over here and we would get that other data set. Those are the records that are not outliers. So that's what we're actually going to do here. And if we run this, we should be able to see that our clean data set has 1,800 and 1,317 records and 8 variables. So yeah, so in that case, we have a clean data set and we can be able to continue with our analysis, having in mind that we have outliers. So something to keep in mind while you're cleaning your data is to ensure that you have some documentation of how you performed your data cleaning and why you performed that particular data cleaning technique, because other stakeholders might want also to go through that particular step if they would want to ensure or verify something. Maybe they might do the analysis and it might not give them their outcome, the desired outcome. They would want to also thoroughly investigate the entire process that was taken to arrive at the analysis, including the data cleaning aspect, and that is important. So if you clean your data, ensure that you have documented why you and how you cleaned your data set. Yeah, so work on the challenges. So once you're done with the challenges, then we can continue to, yeah, so once you're done with the challenges, actually, you can continue to the next course, which will be on data visualization with Python. So it would mean that you have really grasped the concepts that you were meant to have grasped. However, if you still want to work on a project, I would recommend for you to work on the project in the data wrangling with Python course, because the project there helps you to put into practice what you have learned in this particular course. In addition to that, it helps you to also acquire some other new set of skills, which are data wrangling skills, such as some of the ones that we had applied while we were going through some of the problems in this particular section. So if you would want to continue following up on such kinds of crash courses, be sure to subscribe on YouTube. In addition, you could also sign up for the platforms which I had mentioned, the Afterwork Data Science Community, um, Telegram, to just get support and also help other persons who are also learning. And yeah, so I think that's basically it with regards to data cleaning with Python. So we will see each other in the next course, which will be on data visualization with Python. See you then.